car ignition system simulator or a ventilation system, there are three inputs: the potentiometers, where one controls the LCD contrast, one controls piezo buzzer loudness. Another input is the switch. This single pole double throw is the main input of the Arduino project. There are five outputs: the motor, which has 3 speeds, the servo, which has 3 positions, the LEDs, which indicate the state of the switch, and the piezo buzzer, which is annoying and serves as an alarm. Finally, there's the LCD screen, which displays the analog input from the switch. My schematic. My Arduino choice is the Arduino Leonardo. I did not want to use the Arduino Leonardo, but I didn't have a choice as I left my Arduino Mega at school. So, I made do. I do not like the Leonardo, as it seems to never work for more than a day, it has less inputs than the Mega, and overall, I don't like it. There are 6 component areas of interest here: the switch, the piezo buzzer, the potentiometers, the DC motor, servo, and the LCD screen. Let's start with the switch. A switch is a single pole double throw switch which produces 3 states, which is what the program is based around. The switch works by connecting 2 different leads to power or neither, and we can measure this. The piezo buzzer. A piezo buzzer works by applying a pulsating voltage to the piezoelectric ceramic material. This varying or pulsating current comes out as hertz. In this project, it serves as an alarm for when the fan is on or the motor is running. The potentiometers. A potentiometer is a variable resistor. We can use an analog input to measure the potentiometers. In this project, they are used to control the amount of current going to the LCD screen for contrast and the piezos for loudness. The potentiometer has a ground pin, an input pin, and an output pin. The DC motor. A DC motor is any class of rotary electric motors that converts a direct current, DC, electrical energy into mechanical energy. In this project, I use an NPN transistor to control the current going to the motor. A transistor is a semiconductor device that is used as an amplifier or switch to control electrical signals and flow. If you want a more in-depth explanation, follow the link to the description to my video on transistors and logic gates. When the motor turns off, the electromagnetic field collapses and causes a current spike which can damage our parts. To prevent this spike from damaging the components, I use a flyback diode. A diode is a one-way valve. A flyback diode is any diode connected across an inductor used to eliminate flyback, flyback being current going in the wrong direction. The speed of the motor is either off, slow, or fast, as are the 3 states from the switch. The servo. A servo motor is a rotary actuator or linear actuator that allows for precise control of angular or linear position, velocity, and acceleration. Basically, a servo is a motor that is more exact, and we can tell it to go, and it will just go to the angle and stay there. Servos, however, are limited. Our servo can only rotate 180 degrees, is slow, small, and kind of sucks. However, it works for our purposes here. The servo here is to indicate the speed at which we're going the motor, or it can move an object. It's more of a proof of concept in this project that it can move something when the switch is flicked and when the motor is running. The LCD screen. The LCD stands for liquid crystal display. The liquid crystal display, or LCD, is on a flat panel display that uses the light modulating properties of liquid crystals combined with polarizers. Liquid crystals do not emit directly, but instead use a backlight or reflector to produce images in color or monochrome. Monochrome in our case. Our LCD is small and doesn't have many pixels. Our LCD screen can only display text in a 16 by 2 grid, so 32 characters total, 16 characters per line. All the wires coming out look complicated, and they are complicated. No one really knows how an LCD screen works. I don't know how it works. I just plug it in, and it sometimes works. I use the LCD screen to display the analog values from the switch. The code here really is quite straightforward. First, we have the pre-setup stage, because it's before the setup. Here we include the proper libraries that we need, so liquid and servo. We create our pins for motor power, LEDs, switch pins, buzzer pins, you name it. We allocate memory for our variables, switch valve and switch valve 2. We create a servo object, and then we create an LCD object. This is just precautionary, or this is not precautionary, but this is just stuff that you need to get done for the servo and liquid crystal display to work. Here we have the setup stage. The setup stage is, yet again, pretty straightforward. Nothing really interesting happens. It's just we set the servo again. We set the pins to outputs, inputs, highs, lows, all that business. Just really simple stuff. Just getting the pins as outputs and inputs. Now we get on to the main chunk of the code, the loop. The loop starts with serial begin and LCD begin. This is just so we can display information on those. The switch valves. So we first start off by we analog read from the switch pins. So we take the analog reading from the pin that the switch is attached to, and we store it in our variables. We use these variables for these 3 if statements. If the switch valve, so basically if it's over 1020, it's the switch is turned that way and in that state, and if it's below 1020, it's off and not switched that way. Alright, so if the switch valve is, so if this is, we're going to call it left. I'm not sure if it's left. If the switch is flipped to the left, we set one of the pins to high, one of the LEDs to high, one of the LEDs to low, turn on and off. We set the tone, or we tone the buzzer pin, so we just tell it to turn on at a certain frequency, which in this case is A. I'll get to the function I'm using right here. Then we analog write the motor pin to tell it to spin at the max speed. So in this case, when the switch is turned all the way to the left or flipped all the way to the left, the motor runs at max speed. And then we tell the servo to turn all the way to 170 degrees. Next is if the switch is in the middle, so neither. I'm sorry, no, this is it. Yeah, this is if the switch is turned all the way to the right here. So this is, the switch is turned all the way to the right, so this value is 1020, this value is under 1020. We turn one of the pins, we turn both of the pins off, and then the buzzer pin, or the buzzer plays the lowest frequency in the program. We analog write the motor pin to tell it to, it's still sending power, but 155 with this motor is off essentially, but it's still sending a little bit of power, or it's going to be really, really slow. And then we tell the servo to go to 0 degrees. Finally, if the pin is in the middle, okay, so neither is reading 1020, we turn one of the LEDs on, one of the LEDs off, and we set the buzzer pin to the frequency of F. We analog motor pin in between 155 and 255, just like the medium speed or the slow speed, and then we servo write the motor to 90 degrees. Then we just print everything that we need to the LCD screen, the analog values of switch valve and switch valve 2. This was extremely helpful for debugging, and it can be more useful than using serial. This is the function I use for the frequencies. I did not make this. I found this. It's really helpful though, because you just give it the note that you want it to play, and it will play the note. And it does that through arrays and whatnot. So yeah, that is my program.